I'm Marty Hurling. I'm a climate scientist at the National Oceanic and Atmospheric Administration in Boulder, Colorado, and I study El Nino. El Nino has some puzzling aspects to it. It lasts 6-12 months. It returns maybe every 2 to 7 years. When El Nino happens, the ocean temperatures change and the air temperatures change over the whole planet. And they can change by, almost 0.2 degrees Celsius, almost 0.5 degree Fahrenheit. And that kind of change, you might say, well, that's not very big, but actually it is big, and we can see it happening. El Nino is something that causes radical changes. Some places get way too much rain and they get flooded out, and it can be damages to homes. Some areas that normally get rain, suddenly the rain shut down. They get fires, drought, their crops don't grow, a lot of problems. We had this big El Nino this past year. It was so big that we decided within NOAA to go out and hunt it down, take new measurements to see how it ticked. We combine planes, ships, we go to remote islands, we launch balloons.
My name is Dan Wolf. I'm a research meteorologist, and I was part of the El Nino Rapid Response Project. The ship traveled from Hawaii to the equator, collecting ocean temperature and also releasing weather balloons as we went. The data are transmitted real-time back to a computer on the ship where we can watch it. Then we can send it back to Boulder where modelers use it to help better understand the weather and El Nino.
I'm Dr. Leslie Harton. I'm a research meteorologist, and this spring I spent 5 weeks on a small island called Christmas Island in the equatorial Pacific, and we went there to launch weather balloons. Christmas Island is in a part of the world where there are almost no regular weather observations, and it's also right at the heart of the El Nino that was happening this year. We launched our weather balloons at 1:15 in the morning and 1:15 in the afternoon. An instrument package like this is attached to the weather balloon, and as the balloon goes up, we measure temperature and humidity and winds and pressure. Our data give us a really unique picture of how the atmosphere is behaving in that region when there is a strong El Nino.
Hey, Honolulu, this is Boulder, and we're ready to go through the briefing this morning. So every day, the aircraft would have to fly out from Hawaii to the equator to get some idea of what El Nino was doing. Kelly, do you expect both radars on board to be active to help you through that convection?
Yeah, thanks, Marty. We should have both radars working on today's flight, so that will be a big help.
I'm Dr. Kelly Mahoney, and I served as a mission scientist for the El Nino Rapid Response Project aboard the NOAA research aircraft. We had manned aircraft with the whole flight crew aboard it, and then an unmanned aircraft. And the mission of both of these aircrafts was to go out and get close enough to thunderstorms that we could either circle around them or get close enough to feel some of the winds that were coming out of them. As we got close to the thunderstorms, our job was to drop instrument packets out of the airplane to measure the temperature, moisture, and wind speeds right around the thunderstorms. The data that we collected is truly unique and very useful and valuable to our weather and climate models.
So I really like doing this science because we're trying to understand the way El Nino works. The ocean and the atmosphere, how they link. It affects weather patterns. Many people's lives are really affected by this. And that's really why the data are so important. It helps us make better forecasts and helps people's lives.